Hello students, last class, we learned about the lubricating oil system. This class, we will start to learn about the starting or ignition system of aircraft engines. When a gas turbine engine starts working, it needs to use external energy to rotate the rotor. After a starting process, it can enter a stable, slow-speed working state. The various working parts that accelerate the engine from a stationary state to a slow-speed state are collectively called the starting system. When starting the engine on the ground, the starting system and the ignition system work together to start and ignite the engine. When flying, the ignition system works alone. So, what are the requirements for the starting system? First, ensure the starting time required by technical and tactical requirements. Starting time refers to the entire time from the start of the starting system to the acceleration of the engine rotor to the slow speed. For fighters and interceptors, winning time means gaining the initiative in the battle. Second, ensure that the engine can be started automatically and reliably, both on the ground and at the highest possible altitude. Third, under the condition of small system size and light weight, try to ensure the independence of starting and sufficient number of repeated starting times. Fourth, the accessory has a simple structure and is easy to use and maintain. Now let's learn about the engine starting process. The starting process refers to the process of increasing the speed of the engine rotor from 0 to the slow speed. According to the source of the driving force that drives the engine rotor to accelerate, the acceleration process can be divided into 3 stages. The first stage, the driving force that drives the engine rotor to accelerate, comes from the starter. That is, the starter alone drives the engine rotor to accelerate. The rotor speed rises from 0 to N1. N1 equals 0.08 to 0.12 times the maximum speed at which time the starting fuel system starts to supply fuel, ignite burn fuel, and the turbine starts to generate power. Therefore, the starting torque generated by the starter must be greater than the resistance torque of the engine rotor. The second stage, the driving force for accelerating the engine rotor, comes from the starter and the turbine rotor. That is, the starter and the turbine rotor jointly drive the engine rotor to accelerate. The rotor speed rises from N1 to N2. N2 equals January the 2nd to 2nd times the self-sustaining speed. At this time, the starter can be disengaged. The third stage, the driving force for accelerating the engine rotor, comes from the turbine rotor. That is, the turbine rotor alone drives the engine rotor to accelerate, and the rotor speed increases from N2 to the slow speed NED. The above 3 stages are the engine starting process. There are 3 common starters, namely electric starter, gas turbine starter, and air turbine starter. The basic structure of the electric starter is shown in the figure, which consists of a DC power supply, a DC motor, a reducer, a clutch, etc. Its advantages are that it is easy to use and the starting process is automated. Its disadvantages are that it is heavy and the power of the starter varies with external conditions. After starting, the motor becomes useless weight. For this reason, the DC motor can be used as a starter during starting and as a DC generator during flight. The gas turbine starter is actually a complete, small turboshaft engine. As shown in the figure, it consists of a single-sided, single-stage centrifugal compressor, a recirculating combustion chamber, a single-stage centripetal turbine, a single-stage power turbine, a speed reducer, and a clutch. In addition, it should also have its own fuel system, lubricating oil system, starting system, etc. When starting, the gas turbine starter is driven by its own electric starter until the disengagement speed is reached and the starting and ignition systems are disconnected. Then the starter speed continues to increase to the operating speed, and the engine rotor is driven to rotate through a reducer with a large transmission ratio. When the engine speed reaches the disengagement speed, after the self-sustaining speed, the gas turbine starter stops working and is disengaged by the clutch. The engine relies on its own turbine power to accelerate to the slow speed. Its advantages are high starting power, no reliance on ground power, and can be reused many times. Its disadvantages are complex structure. The figure shows an air turbine starter, which consists of a single-stage turbine, a reducer, a clutch, and a transmission shaft. The air required by the air turbine can come from a ground air source vehicle, an auxiliary power unit, or a started engine. The advantages of an air turbine starter are high torque, lightweight, simple structure, reliable operation, and easy use. Its disadvantage is that it requires an external air source and cannot start the engine alone. At present, electric starters and starter generators are widely used in small thrust engines and auxiliary power units. Air turbine starters are mostly used in large passenger aircraft and transport aircraft. For engines of the same brand, different types of starters can be used due to different types of engines installed. For the ignition system, all gas turbine engines use high-energy ignition devices and are always equipped with dual systems. The function of the ignition system is to generate an electric spark to ignite the mixture. The ignition system of a gas turbine engine is shown in the figure. It consists of a power supply, a high-energy igniter, a high-voltage wire, and an ignition nozzle. The output of the igniter has both high-energy output and low-energy output, so it is a composite ignition system. The ignition system of a gas turbine engine has the following features. First, it only works during the starting and ignition process. Once a stable ignition source is formed in the combustion chamber, the ignition system stops working. Second, adopt high-energy capacitor composite ignition system. Third, the ignition system has no effect on the performance of the engine. The input power of the igniter is of two types, direct current and alternating current. In the interrupter type DC ignition device, shown in the figure, the DC interrupter operating device has an induction coil, which is operated by the interrupter mechanism to charge the energy storage capacitor through the high-voltage rectifier. When the voltage in the capacitor rises to the breakdown value of the sealed discharge gap, the energy is released through the end face of the ignition nozzle. The basic structure of the transistor DC ignition device is shown in the figure. Its operation is similar to that of the device operated by the DC interrupter, except that the transistor interrupter circuit replaces the interrupter device. The high-voltage AC ignition system is provided with 115 volts 400 Hz AC power by an AC power supply. As can be seen from the figure, it consists of a transformer, a rectifier, an energy storage capacitor, a discharge gap, a choke coil, a discharge resistor, a safety resistor, and an electric nozzle. The function of the nozzle is to generate sparks to ignite the mixture. The nozzle, currently used in aviation gas turbine engines, is a surface discharge nozzle. As shown in the figure, this nozzle is filled with insulating material between the shell and the center electrode. The front end of the center electrode is a tungsten electrode head covered with a layer of silicon carbide semiconductor material. When the ignition system is working, the high-voltage electricity of the high-energy igniter is transmitted to the nozzle through the high-voltage wire. The high-voltage electricity on the center electrode causes ionization on the surface of the semiconductor insulating material between the center electrode and the shell, providing a low-resistance path for the electric energy stored in the capacitor. The discharge takes the form of high-voltage sparking from the electrode to the shell, forming a high-intensity spark. Students, in this class we learned about the engine, starting or ignition system. Understanding the three stages of the engine starting process is a difficult point. I hope that students will review it in time after class and digest and absorb it. Thank you.